Assalamualaikum and hi. In this video, we're going to share about you guys about our soil project that is construction of a snack factory of a deep soft soil deposit at the Kawasan Industri Kendal. First of all, I'm going to introduce my team. That is our leader is Muhammad Naim bin Wazir, and followed by our members is Nur Izzah binti Samsuri and Muhammad Faiq bin Zamzam, and me and myself is Muhammad Fikri bin Muhammad Puzri.
Alright, firstly I will present about introduction. The process of ground improvement involves using mechanical tools to improve poor ground conditions. Poor soil conditions can be improved by simply digging and adding soil or by using a deep foundation. Both methods are often more expensive, useful to just treat the soil to fix it where it is. Alright, next is about problem segment. First is clay is one of the problematic soils due to its natural state of having low bearing capacity and high compressibility. Next is clay also complicates construction such as building embankments for roads, railways or landfills for housing projects may bring problems related to instability during construction and long-term and continuous solution length. Negative of skin friction that need to be considered in the pile design also is a problem, and the foundation of the SPT pile needs to be over 30 yet not from the 80 meter. And lastly is soil data show that soft clay is more than 20 meter. So the objective of this project is to prepare the ground improvement proposal by using rigid inclusion, and next we make a calculations taking into account bearing capacity and settlement estimation. Lastly is to prepare innovation proposal by using GeoGrid. That's all from me.
Rigid inclusion. Rigid inclusion is a ground improvement method using the high deformation modules columns constructed through the compressible soil to reduce settlement and increase the bearing capacity. Ground improvement efficiency depends on the stiffness relationship between the soil and the columns. Types of rigid inclusion: geoconcrete columns, drilling displacement columns, grouted ramp aggregate pier system, armor pads, confinite ramp aggregate piers, precious grouted ramp aggregate piers.
Next is the advantage of a rigid inclusion. Number one is the minimal spoil, and number two is reduce settlement very efficiently. And the next one is increasing the bearing capacity of weak soil even for a high load. And the number four is allow the use of a shallow foundation to support the structure on a compressible soil. And the last one is can be used in all construction sector and apply for most type of structure and soil types. Okay, the next one is the installation. Okay, the first one, the contractor will install the rigid inclusion by laterally displacing the soil. And the next one is the LTP is installed on the top of the rigid inclusion and is composed of a layer of a granular. And the third step is a FEM to design the column to provide the desired bearing pressure and meet the settlement criteria. And the last one is the rigid inclusion are installed in a tandem with the aggregate piers.
Geotechnical problem and innovation. While working on larger construction projects, it is even more critical that the architect and engineer understand exactly what is going on in the soil structure surrounding the building. Several concerns may be discovered during geotechnical survey. Some problems may be resolved in order to construct a truly safe building, but others may result in the project's termination. This is entirely dependent on the nature and severity of the problem discovered. Next part is rigid inclusion ground improvement as an alternative to pile foundation. Buildings today confront a slew of demands and specifications. One of the most crucial is to maintain the structure and user safety. Nowadays, there is frequently an extra economic factor associated with the investors or contractors' willingness to minimize building costs and time of completion. First, columns are more flexible elements that are normally finished in a bearing layer of less than 1 meter, since the column system must be settled in order to move the soil. Otherwise, the columns will take up practically all of the load and behave almost identically to piles. The consideration states above may point to the benefits and superiority of reinforcing the earth with rigid column over deep foundation. Column strengthening that is correctly designed and built may result in considerable saving in both money and time. Innovation of ground improvement. We highlight the enhancement we employed to further reinforce the ground improvement in order to support the greater weight. We employ the geogrid approach as an innovation. A geogrid is a geosynthetic material used to reinforce soils and similar materials. Soil pull apart under tension. Compared to soil, geogrids are strong in tension. This fact allows them to transfer force to a larger area of soil than would otherwise be the case. Why we choose these materials? These materials can increase bearing capacity. It also can mitigate differential settlement. It can reducing pavement of thickness, and it can increase pavement life.
As a conclusion, we completed this project by analyzing and solving the problem that arise during the course of the project. The goal of using soil mechanics varies depending on the project, but is generally aimed to ensure soil stability, limit deformation, and control groundwater flow. Following that, as a result of our experience completing the soil improvement method project, we now have a better understanding of the various methods available to help improve soil. We choose rigid inclusion and innovative ground improvement method in addition to geogrid because we found many advantages and cost saving. Based on the information provided about the project's problem, we are confident that this method can exist. That's all from us. Thank you.